Okay, let's jump right into it. We're doing a deep dive today into something pretty fundamental for ensuring quality and preventing problems, well, before they even happen. Failure mode and effects analysis,
FMEA. Yeah.
FMEA for short. Essentially a structured way to anticipate where things might go wrong and understand the consequences.
That's the core idea, absolutely. It's all about being proactive, really. Spotting those potential failure points, maybe in a design or a manufacturing process, before they cause, well, real headaches down the line.
Right. And our specific focus today is a pretty big evolution within this field. It's especially relevant if you're involved in industries like, say, automotive.
Hmm.
We're unpacking the shift from the previous AIAG FMEA method
Hmm.
to the newer harmonized AIAG-VDA FMEA Handbook that came out in 2019.
That's right.
And just so you know, everything we're discussing today comes directly from the source material you shared with us.
And it's a significant transition, this handbook, because it really changes how organizations identify, analyze, and crucially, prioritize risks. The clear aim is enhancing quality and safety.
Especially in that complex global automotive supply chain, I imagine.
Exactly. Bringing more consistency and, frankly, more rigor to the whole process.
Okay. So for this deep dive, our mission, if you like, is to cut through the jargon and give you the essential knowledge about this major change.
Yeah.
We want you to understand the key shifts, the sort of why behind them, the tangible benefits, and also the real-world challenges organizations are facing as they adopt this new standard.
Makes sense.
We'll walk through the history a bit, what exactly is different, the advantages this new approach offers, the hurdles in actually putting it into practice, and, some lessons learned along the way.
Sounds good. So FMEA itself, it has a history, goes back decades, really. It's evolved as industries matured. In the automotive sector, the Automotive Industry Action Group, AIAG, became a key player in standardizing FMEA practices, especially for design FMEAs, DFMEAs, and process FMEAs, the PFMEAs.
And the previous standard was the AIAG FMEA 4th edition.
That's the one. It was widely used for quite some time.
And based on the sources, how would you describe that previous AIAG method? What was its sort of defining characteristic?
Well, it was certainly effective, up to a point, but the sources describe it as being less structured, or maybe less prescriptive is a better way to put it.
Okay.
It didn't have a really rigidly defined sequence of steps that every single FMEA team absolutely had to follow.
So more flexible, maybe?
Flexible, yes, but that flexibility could sometimes lead to inconsistencies, how FMEAs were done across different projects or even different teams in the same company. And the collaboration aspect, it wasn't as formally built into the process structure.
Gotcha. So the drive for this new standard, it wasn't just about updating a document then. It was more fundamental, addressing inconsistencies, pushing for a global standard.
Exactly. That's the heart of it. The increasing globalization of the auto industry made these variations in FMEA practices between regions, well, problematic.
Right.
That led to this significant collaboration starting around 2017, I think, and it culminated in the 2019 handbook. It was a joint effort between AIAG here and the German Association of the Automotive Industry, the VDA.
Okay, the AIAG-VDA Handbook.
Yep. And the goal was explicitly stated: combine the strengths of both the American and the German ways of doing FMEA into one single harmonized document.
And the core of this new harmonized approach, it sounds like it's built around a much more, explicit structure.
It absolutely is.
Yeah.
The AIAG-VDA Handbook introduces a mandatory, quite rigorous 7-step framework.
7 steps.
And these steps, they're laid out sequentially. It starts with planning and preparation, then structure analysis, function analysis, failure analysis, risk analysis, then optimization, and finally, results documentation.
Wow, that move to a mandatory 7 steps, that feels like a really deliberate design choice.
Yeah.
What's the intended effect of,
Yeah.
enforcing that sequence?
Well, the intention is definitely to bring transparency and discipline to the process. By following these steps, and importantly, in order, teams are guided systematically, all the way from defining the scope right through to documenting the outcomes. It creates a kind of common language, a common roadmap. And that helps collaboration, not just within the FMEA team itself, but also with management, customers, suppliers, everyone involved.
Okay, that provides the historical context and the new structure. Makes
Right.
sense. Now let's get into the specifics that practitioners, people doing this day to day, really need to know. What are the most significant changes you see when you compare the old AIAG FMEA to this new AIAG-VDA Handbook?
Okay. Well, one of the most impactful changes, and definitely one that sparked a lot of discussion, is the fundamental shift in how risks get prioritized.
Ah, prioritization.
Okay.
Okay.
The previous method, it relied heavily on the risk priority number, the RPN.
Right, I remember RPN. You multiply severity, occurrence, and detection.
Exactly. You multiply those three ratings together to get a single number.
And the sources point out a key problem with that RPN approach, don't they?
They do,
Yeah.
yes. The major issue was that very different combinations of severity, occurrence, and detection could end up giving you the same or very, very similar RPN values.
Right, so it hides the details.
It created ambiguity. It made it genuinely difficult sometimes to decide which failure modes were truly the highest priority for action. You know, a high RPN from high occurrence but low severity might look the same on paper as one from low occurrence but really high severity, even though intuitively their risk profiles feel very different.
Yeah, I can see that. So how does the new AIAG-VDA method tackle that specific problem?
So they moved away from that single RPN number entirely, and they introduced the action priority, or AP, method.
AP, yeah?
This is more of a qualitative assessment. It's focused on criticality. And the crucial philosophical shift here is that it gives absolute precedence to the severity of potential failure.
Severity first.
Severity first. It effectively creates these matrices based on severity, then occurrence, and then detection, and assigns a priority level high, medium, or low for taking action. This change directly tackles that RPN ambiguity by forcing teams to focus first on the potential impact. It makes the prioritization clearer, less prone to, misinterpretation.
That feels like a major mindset change, really putting severity right up front. What about how the pieces of the system itself are broken down and analyzed? Is there a difference there?
Yes, definitely. The AIAG-VDA method significantly ramps up the requirement for a systematic definition of the relationships between structure, function, and failure.
Okay, structure, function, failure.
Right. It's not enough just to list potential failures anymore. You need to clearly define what the system is, what its parts are supposed to do, that's the function, and then how those parts or the overall system might fail to perform those functions.
More rigorous.
Much more. The new handbook really pushes the use of detailed diagrams and visual tools, things like block diagrams, boundary diagrams, structure trees, tools to clearly map out these relationships. This systematic visual approach, it makes the analysis more thorough and helps ensure consistency, especially across complex systems. That was less formalized in the previous AIAG method.
And of course, the 7 steps themselves are a huge methodological difference we already touched on.
Absolutely. That 7-step process isn't just a suggested guideline anymore, it's the defined method. It's really designed to ensure that the FMEA isn't just a one-time document you create and file away.
Ah, the living document idea.
Exactly. It's meant to be started early and updated throughout the product or process lifecycle. The lack of this defined sequence in the previous method made it harder, arguably, to maintain the FMEA effectively over time as things changed.
And the fact that this came from a collaboration between AIAG and VDA inherently points to global standardization. How impactful is that really in practice?
Oh, it's incredibly impactful, especially for multinational companies and, these sprawling global supply chains.
Right.
The harmonized handbook means, ideally, using the same methods, the same terminology, whether you're in Detroit or Stuttgart or Shanghai. This reduces confusion, it improves communication, and crucially, it eliminates the need for suppliers to manage multiple, slightly different FMEA approaches just based on regional preferences or different customer demands.
Okay, that all sounds like significant progress. Clear prioritization with AP, better system analysis, a defined process, global consistency. But the sources also mention some concerns, maybe some debates, about the increased complexity.
They do. That's fair. While the intent is clearly positive, the new standard is more detailed, it requires more rigor, and that naturally adds complexity. There's no denying that.
And some critics worry about that.
Yes, some critics, and the sources acknowledge this debate, raise the point that this increased complexity might not always translate into genuinely better FMEA outcomes in every single situation, particularly perhaps in certain contexts like North America, where the previous method was deeply ingrained. There's a valid concern, I think, that if the process isn't implemented correctly or maybe over-implemented, the added complexity could potentially make the FMEA less effective, not more, bogged down in the process maybe.
That complexity point definitely resonates. But focusing on the intended results, the positive side, what are the key advantages organizations are finding by adopting the AIAG-VDA FEA based on what the sources say.
Well, that structured process we keep coming back to, that's really the foundation for many of the advantages. That seven-step framework brings a level of transparency and discipline that significantly enhances cross-functional collaboration.
How so?
Because everyone knows the steps, they know the inputs required for each step, the outputs expected. It creates that common ground.
And how does that structure translate into better risk analysis? You mentioned the action priority.
Right. By forcing that systematic evaluation through the steps, especially with the action priority focusing on severity, first teams are just better equipped to identify and prioritize the most critical failure modes. It's not just about listing everything that could go wrong. It's about directing resources effectively to prevent the failures that would have the most significant impact.
So better focus.
Better focus, ultimately helping prevent costly issues and ensuring safety and reliability.
Okay. And you mentioned collaboration being enhanced.
Yes, definitely. It really pushes for dialogue, not just between, say, engineering and quality, but also involving manufacturing, purchasing, maybe even customer service representatives who hear about field issues.
Bringing more people into the tent.
Exactly. The sources highlight how this broad involvement makes the FMEA more robust. It helps ensure the mitigation actions decided upon are actually practical and widely supported across the organization. It also builds a kind of shared understanding of the technical risks right through the entire supply chain.
And we can't overlook the global aspect again, I suppose. That consistency must be a major advantage.
It is. For any company operating internationally or supplying to global OEMs, having that unified framework is a major plus. It standardizes communications, standardizes expectations, and reduces the overhead and, frankly, the potential for errors that came with managing all those different regional FMEA requirements.
Is there also a focus on validating the actions that are taken, making sure they actually work?
Yes, absolutely. There's a strong emphasis placed on the optimization step. That includes monitoring and testing the effectiveness of the actions you implement.
Closing the loop.
Precisely. It's not just about putting controls in place, it's about verifying they actually work as intended. This closed-loop thinking encourages continuous improvement. It pushes teams to refine their processes and adapt as the product or the process evolves over time. And this continuous cycle also helps organizations maintain compliance with demanding standards like ISO 26262 for functional safety.
Okay, the benefits are definitely compelling structure, more targeted risk analysis, enhanced collaboration across the board, global consistency, and that focus on continuous improvement makes a strong case. But moving to such a detailed new standard, it can't be easy. What are the practical implementation challenges organizations are grappling with, according to the sources?
Yeah, it's not without its difficulties. One of the initial hurdles mentioned quite often is simply getting everyone aligned on the scope of the FMEA right at the start.
Defining the boundaries.
Defining the boundaries, yeah. And ensuring that those crucial cross-functional teams we talked about are truly effective and properly engaged right from the outset. It requires, dedicated effort to really foster that collaboration effectively.
And the documentation requirements sound pretty substantial, too.
They are. Creating FMEA reports that effectively summarize all that detailed analysis for different stakeholders. Management needs one view, customers another, suppliers perhaps another, while meeting all the handbook's requirements. That's a challenge.
Finding the right level of detail.
Exactly. You need to communicate the key technical risks clearly as part of the bigger picture of development, while also managing the very detailed documentation that supports it. And sometimes you have to navigate protecting intellectual property within that process, too.
I can imagine that complexity gets exponentially worse for suppliers who are dealing with multiple different customers, multiple OEMs.
Oh, that's a huge point raised in the sources, especially the burden on suppliers lower down the chain. Think tier 2, tier 3, and so on.
Right.
The variations in customer-specific requirements, or CSRs, from different OEMs layer significant complexity right on top of the new standard itself. Managing all these diverse CSRs from various customers, it adds compliance complexity. It adds cost.
So the standard isn't quite standard if customers add their own layers.
Well, yes. And David Neisler is quoted making a crucial point here. He highlights that a truly standardized approach is still needed, specifically to ease the burden on these lower-tier suppliers who often face the brunt of this variation. They might have to adapt their FMEA process slightly for each major customer.
That sounds inefficient. And even having the right software tools doesn't automatically solve the problem.
No, that's another challenge highlighted. Even when organizations invest in the same FMEA software tools across the board, if they end up using them differently across various plans or different design centers or even for different OEM projects, well, that can lead to inefficiencies and non-value-added work, basically rework.
So consistency in tool use matters too.
Absolutely. The sources emphasize that unified tool application across the organization is really essential to streamline operations and avoid adding unnecessary complexity back into the system.
So it's not just about adopting the new handbook itself. It requires a broader strategy for implementation, doesn't it?
Exactly. The sources strongly imply that you need complementary strategies, clear internal standards for how you're going to apply the new framework, and consistent tool usage to really navigate the transition successfully.
The source material also draws on insights from practical case studies, doesn't it?
Yeah.
Organizations actually implementing this AIAG-VDA approach.
Yeah.
What are some of the key lessons learned from those real-world experiences?
Yeah, those case studies are interesting. And a recurring lesson, one that strongly supports what we were just discussing about collaboration, is the absolute necessity of involving truly cross-functional teams in the FMEA process. It came up again and again.
Okay, so what happened when teams weren't properly cross-functional? Did the case studies show that?
They did. The finding was pretty clear. Limiting participation, maybe just having engineers and quality personnel involved, for example, frequently led to critical failure modes being overlooked entirely, or perhaps their effects being misjudged.
Blind spots.
Exactly. The case studies really underscore that you need that diverse representation. You need perspectives from the people who actually build the product on the line, maybe people who service it later, alongside quality, engineering, purchasing, all the relevant areas.
Makes sense. And how does this more structured, collaborative FMEA framework directly tie into optimizing the actual design and manufacturing processes?
Well, it's designed to be integrated throughout. For the design side, the DFMEA helps identify potential failures really early in the development cycle. By systematically analyzing those risks, teams can implement preventative actions, optimize the design itself, and then, crucially, document all of this for future reference and, well, continuous improvement.
And how does the manufacturing side benefit directly?
So the PFMEA, the Process FMEA, focuses specifically on the process risks, identifying where the manufacturing or assembly steps could introduce defects or failures. The new framework really encourages clear communication between design and manufacturing.
Breaking down silos?
Hopefully. Shared information about the design intent, critical characteristics identified in the design, potential failure modes already flagged in the DFMEA, all that is crucial input for creating an effective PFMEA and making sure the manufacturing process is actually designed to prevent those known issues.
And those visual tools we mentioned earlier, like structure trees and block diagrams, are they used in both design and process FEA?
Yes, their use is emphasized for both. During design, they help teams break down complex systems and understand interfaces. In manufacturing, they can help map out process steps and their relationships, material flows, and so on. Using these consistent visual tools helps ensure everyone involved understands the system or the process structure, which is really foundational for identifying potential failures accurately and maintaining consistency between the DFMEA and PFMEA.
Okay, just to be crystal clear for everyone listening, can you briefly summarize again the core difference between a DFMEA and a PFMEA, and why an organization really needs both?
Sure. Think of it this way. DFMEA is about the thing, the product design itself. What could fail because of how it's designed? Are the tolerances right? Is the material suitable? That kind of thing.
Okay, the design.
PFMEA is about how the thing is made, the manufacturing and assembly processes. What could go wrong because of how we build it? Is the machine set up correctly? Is the operator trained? Is the inspection method reliable?
The making of it.
Exactly. And you absolutely need both, because potential failures can originate from either the design choices or the manufacturing execution. Using both DFMEA and PFMEA gives you that crucial, holistic view of risks across the entire product lifecycle, from the drawing board right to the factory floor.
And that AIAG-VDA emphasis on documentation we talked about, that supports this holistic view.
Absolutely. The requirement for thorough documentation in both DFMEA and PFMEA serves as a comprehensive record. It captures the identified risks, their analysis, the actions taken to mitigate them, and importantly, this documentation isn't meant to be static.
Right, the living document point again.
It's intended to be updated as designs change or processes get refined. It provides a vital reference point and, yes, a structured framework for that continuous improvement we discussed earlier. Allows you to learn and adapt as systems evolve.
Wow, okay. We've really covered a lot of ground here. We've gone from the uh, less structured, RPN-focused past of AIAG FAA to this new, highly structured, collaborative, severity prioritizing, and globally harmonized AIAG-VDA approach. It's clear this is a major evolution, packed with potential benefits for sure, but also bringing some very real implementation challenges.
It really is a significant undertaking for any organization that adopts it. It reflects the ever-increasing demands for quality, safety, and reliability, especially in complex global industries like automotive.
So as you reflect on everything we've pulled from the source material today, the detailed steps, the focus on severity, the intense documentation, this whole idea that the FMEA is supposed to be a living document that evolves throughout a product's entire life cycle. Here's a final thought for you to ponder. Considering products can be in the market sometimes for many, many years, maybe even decades, what do you think is the most persistent, practical challenge in truly keeping that living document alive, updated, relevant, and genuinely useful over that entire, potentially very long lifespan?